Hey you folks, QuillyTeam here, and welcome to a brand new Unity tutorial. This time we're going to be doing something I'm going to codename Project SpaceCube. We're going to do one of those games where you sort of, take some cubes and glue them together to make a spaceship and then throw some engines on there and have them go. And this is something that is actually remarkably simple to get started with, and it's going to give us a good opportunity to do a tutorial that is very sort of Unity centric, right? To contrast with Project Porcupine, Project Porcupine involved a lot of sort of just custom plain vanilla C# classes that all operated basically independently of any sort of game engine, and then we had an interface on the Unity side to show that on the screen, but we weren't really doing Unity things too much, and this one is going to be very Unity. Also, it's going to be a fair bit shorter. I expect somewhere at the most probably a dozen episodes as opposed to the dozens that we had to use for Project Porcupine. It's going to be a lot of fun. We're going to build a sort of physics-enabled spaceship that you can use simple mouse clicks to sort of add more components onto. I want to be able to customize, have some engines or thrusters on there and be able to customize which hotkey controls each thrusters. And then you're going to be using this to fly your little ship around, and maybe we'll make a little obstacle course. So what we're going to do is we're going to learn how to spawn objects in Unity, or, specifically spawn them with a mouse click here. More importantly, we're going to learn how to place things based on where your mouse is. It's pretty easy to create an instance of an object in Unity, but to actually place it based on your mouse is something that a lot of people have requested we haven't really looked at before. It's very easy to do, and it's going to be fun to do it. Another thing is we're going to be taking a physics-enabled object and changing it dynamically by adding, say, more of these cubes as we go. And there are certain caveats and gotchas that you're going to want to pay attention to that. We're also going to have a discussion of different ways to optimize mesh geometry, because we're going to be taking a bunch of cubes and sticking them together. And there are ways to optimize that final set of cube combinations for rendering. We're maybe not going to implement them, but we're going to discuss a few different ways that you can optimize that if you're looking to make very big and very complex ships, which we're probably not getting around to. We're going to implement multiple camera modes, which I think is going to be very handy for our work. And then we'll, at some point, make a little obstacle course so we can fly around in and test what we are doing. It's gonna be fun. It should be relatively fast and relatively easy. If you are new to Unity, this should be perfectly fine to follow. If you're completely new to C#, you probably can follow it. I have done a mini C# introduction tutorial as well on my channel that you can look for if you need to know the very basics of like what a variable is and what an if statement works like. But other than that, we're going to keep things relatively simple. All right, so we've got an empty project here in Unity. I did go ahead and pull in a couple of assets that we're going to be using later, but what we're going to do to start off with is we're going to create ourselves a basic cube. We're going to use one of the standard Unity cubes over here. We're going to make it a little bit prettier as well. Over here in the images folder, I've got this texture that I brought in. I'm just going to go and create a new material over here, because you don't apply images to 3D objects directly. Use a material. The material describes how this object will appear once it is rendered. So I'm going to call this one, say, something like matte box side. The naming doesn't matter, although, it's nice to stay organized. And we're going to apply this material to our cube. This cube, of course, has a mesh renderer on it. The mesh renderer uses the information from the mesh filter over here. Mesh filter is the information about the vertices, the sides, the triangles that make up an object, and the mesh renderer is responsible for turning that into something visual by using a material. By default, it's got this, default material, which is this sort of, I guess, just white material over here. So what I'm going to do is I'm going to drag our matte box side material into this slot over here under materials element 1. This is an array of materials that you can expand. You can also, there's a shortcut, if you just drag the material onto the object itself, it does automatically set it over there. Currently there's nothing to see, but I could take this material and recolor the albedo over here to change the color of the cube. But what I'm going to do here is I'm going to leave the basic tint to white, and in the little box next to albedo, I'm going to drag the texture into there to colorize our cube. Excellent, looking wonderful. So if you've got your own cube texture, you can go and throw it on now. It's not really important. Or you can download the project down below in the links and grab my images from over there. All right, so I've got this basic cube here. Now, what we want to do is we want to make it so that when we click on this cube, like on a side, it's going to spawn another one, right? We're trying to glue more cubes onto this one to start off with. We are going to use some more complex shapes later on. Sneak peek into the materials over there. But for now, we're just going to be gluing cubes together, which is going to be a fun little challenge on its own. So let's think about the process that's going to happen here. We want it so that when we put our mouse over the cube, and click, actually it's going to be in the game view over here, we want to instantiate another copy of this cube, or some object of some kind. Let me go and take this camera first, and I'm just going to go and adjust where the camera is, just so it looks a little bit more interesting. I'm going to put it off kind of to the side here, and then just rotate it this way, and perhaps I'll put the camera up a little bit higher as well, and then rotate on the x-axis. There we go. That'll look all right. There we go. That's going to be much better because this is the screen we're going to be working in over here. And of course, I always go and hit Control S compulsively to save the project. So we'll go ahead and save the scene over here. Okay, great. Now, if you want the cube to respond to mouse clicks, which is our next step here, there's a couple of different ways to do it. The sort of like de facto, it's more straightforward and obvious way to do it is you can attach a script to this cube and have a function in that script that responds to the various on-mouse blah events, on-mouse enter, leave, on-mouse down, on-mouse click, all those sorts of things. The thing is, that's kind of sort of a trap. Almost every project that I've ever worked on where I have started by using those on-mouse whatever events on the object itself as a component, I've eventually run into problems and moved into a centralized manager. And in this case, it's definitely going to be the case that that would be a trap for us, because the problem with using those Unity events where the object itself gets signaled when the mouse is over it or clicks on it or something, is you are dependent on Unity's rules to determine whether the mouse is on the object, if there's another object in front of it, which objects do we ignore or not ignore, so on and so forth. It's far, far better, and trust me on this, if you just build a centralized script on your own to manage the mouse and figure out if the mouse is over something. And it gives you the ability to ignore different object types. Also have, it's an easier way to manage if you have multiple modes, which we were going to have later on. We're going to start off by just having, we're going to be in our quote-unquote edit mode here, where we can create blocks and cubes. But later on, we might want the mouse instead to say, spin the camera around like this, instead of spawning cubes, for example. So you might have modes, and it's a little bit more convenient probably if you have a central manager for all that. So what I'm going to do, and this is something I like to do a fair bit, I'm going to create a new empty object in our scene. And I'm going to name this one script. In fact, I like to go underscore scripts like this, make it super obvious. And it doesn't matter where this object is. You could have like 1,000 or 10,000 units off to one side to keep it out of the way. Some people prefer to keep it at 0, 0, 0. It really doesn't make much of a difference. If you find that this object gets in your way, shove it way aside. Otherwise, it might be better to have it at 0, 0, 0, just in case somewhere along the way you start doing some math, some positional math, and you forget that, consider offsets or something of that nature. Probably not going to happen. So we got this scripts object over here, which means now what I can do is I can create a new C# script, which I'm going to call something like mouse manager. I guess that's pretty fine. I'm going to create this mouse manager script, and then I'm going to add it to the scripts object. So the idea is mouse manager is going to be a standard Unity mono behavior. It's just a component that responds to things in the scene. And as such, it has to exist in the scene. And there's other ways that you can sort of instantiate these managers without having them necessarily be attached to a game object. But this is perfectly fine and very straightforward. So now that we've got that, we can open this up in mono develop. And then what this is going to do is it's going to be responsible first for knowing, are we over a cube? If the mouse, okay, sorry, let me back up there. Has the mouse been clicked? If so, is the mouse currently over a cube? And if so, then let's go and spawn a new cube at an appropriate location. So let's tackle that first part first, which is a pretty good order to do things in. So here we are over here. We've got our standard script. And what we want to do is respond to mouse clicks. Now, again, if this were a component that was on our cube, we could use that void on mouse, on moose, yeah, on moose, there we are, on moose, whatever kind of functions. That is not the case here. How do we know if the mouse has been clicked down inside of this manager? Because there's nothing that's sort of responding to it. There's no way we can just ask the system, well, with the event system, there's sort of ways. We can't just hook in and say, hey, listen, whenever the mouse gets pushed down, call this extra function. Instead, what we're going to do is every frame, every update, we're going to check, was the mouse not clicked, but pressed down this frame? And we can do that very easily with if input dot get mouse button. So get mouse button returns true if the mouse button is currently being held down. That's not really what we're looking for. What we're looking for is get mouse button down, which returns true if the mouse went from not being clicked to being pushed down this frame. This only returns true once. No matter how long you hold down hold down the mouse button, this will only return true on the one frame where it went from being up to being down. And there's also get mouse button up. Do test on these. Sometimes, depending on how you want your user interface to work, sometimes it's actually better to trigger your events on mouse button up as opposed to down. Here, I don't think it really matters. This requires a number that indicates the mouse button. 0 is the left mouse click. So, which is what we're going to use right now. Yes, the left mouse button was pressed this frame. Okay, so now the question is the mouse over a cube? We're just going to say cube for now, but later on we'll actually have considerably more shapes. And this is a very standard operation to do in Unity. We are going to cast array. Basically, if we look at our camera over here, let's get the main camera, look down. What we're going to do is we want to know if we're over a cube here, what we're going to do is we're going to shoot a ray, basically a beam, from out of the camera, which is, of course, that's our viewpoint, right? Our viewpoint is the camera. So we're going to shoot a ray out of the camera along a direction and see if it hits a box. And the way we determine what direction the ray can shoot in is going to be based on the mouse's position in this window, in the game window itself, whether it's full screen or not. You know, the little game area here, whether we're from the top left corner or the bottom right corner, somewhere in there, we're going to use that information to give a direction to this ray. So the ray, if the mouse is right in the middle of the screen, for example, the ray will get shot out directly in the direction of the camera. Or if it's more off to the right, then the ray will get shot off towards the right. But in any case, we're going to find out if it hits an object. Now, to do that, very simple. So first what we're going to do is we're going to create the ray. There's a class to hold ray information, so ray sounds good. And you can create a new ray like this, and you can feed it in some information. A ray basically contains an origin, where does the ray start from, and a direction. And we could feed that in manually, and that's perfectly fine. In fact, if you're doing a first-person shooter, you're often going to be doing these ray casts to find out, when the player shoots, well, did the player hit anything? With a first-person shooter, your bullets are basically always coming out directly from the middle of the screen, right? You'll probably have a little crosshair in the middle of the screen, and so you're always shooting forward. And the easiest way to do that is the origin is just the camera's position. Let me just do a little placeholder thing over here, the camera. We're going to figure out what that is in a moment here. But you're always going to be using the camera's transform.position as the origin, and you're going to be using the camera's transform forward direction as the direction of the ray. This is if you're doing a first-person shooter and you don't care about the mouse position. But we do care about the mouse position. We're not always going to look at the middle thing in the middle of the camera. If we click over here, then we need to take that into account. Luckily, there's a very, very, very handy helper for us when we do that. First of all, let's get the camera sorted in here. There's a bunch of different ways to get a reference to the camera. Keep in mind, your scene might have more than one. The easiest way to get the camera is to use something like camera.main. This is a shortcut that will return the main camera. What is the main camera? Well, the main camera is the first camera in the scene with the tag set to main camera. Note, if for some reason, save first, if for some reason you had deleted the camera and then created a new one, by default this camera comes in untagged, which means that camera.main will be null and invalid. So if you do that, you have to make sure to set your new camera to the main camera, and then camera.main will work. Let me just undo. If you happen to have two cameras both tagged with main camera, then this will still work. It'll return, I think, the first one, but that's kind of inconsistent. For safety, the other thing you could do over here is we could have a public reference to a camera called the camera, something like this. And then if you look at scripts in the inspector, it will have this placeholder, and you can link it by dragging things that way, which is potentially a little bit safer. What I'm going to do, though, is I'm going to say It's fine. We've got just one camera in our scene, camera.main. We'll do that. In fact, I don't need this sort of variable anymore, but just for the sake of clarity, I'm going to do this. All right, so what we need to do is we need to shoot a ray that comes out of the camera, but in a direction that is offset by the mouse. There is a handy-dandy helper, as I said, on the camera itself. It's got two functions to help you shoot a ray in a correct direction. There is viewport point to ray. Now, the viewport is this area over here, right? Now, your actual camera doesn't necessarily need to render to the whole screen, which is kind of a funny thing. You can see here on your camera itself, it's got this viewport rect variable. And let's say I change the width to 0.5. Now the camera is only going to cover, or maybe even the height by 0.5. Now this camera is only rendering to a quarter of the screen. You can have multiple cameras. Let's say I take this camera, double it up, and then set its coordinates back to full size, and then change the depth. There we go, like this. So we get two cameras, one rendering here and one rendering full screen, but at a deeper depth. This can be handy for all kinds of different kinds of games, where you have picture-in-picture or something like that. It's a very cool effect, but that's what the viewport rec responds to. I'm going to go and delete you and reset you back to 1. If you use the viewport point, then you're going to have to feed it coordinates that go from 0 to 1. 0 in the X is the left side of the screen, 1 is the right side of the screen. In the Y direction, 0 is, I believe, the bottom of the screen, and 1 is the top of the screen. But we don't want to work with this one specifically. What we're actually going to use is and it does work. You can map the mouse to the viewpoint coordinates. That's fine. But for our purposes, screen point to ray is perfectly fine. And the reason I'm going to prefer this is because input.mouse position, right over there, lowercase m, sorry. Input.mouse position is technically a vector 3, although the z component of it's not really used. It's just the x and the y coordinates returns the pixel coordinates of the mouse on the screen. And screen point to ray uses that. You feed it in some pixel coordinates, and it returns a ray that comes out of the center of the camera and veers off in a direction based on the mouse position. If the mouse position, so let's say for some reason our screen size here is exactly 500 by 500 pixels, then the middle point would be 250, 250. If for some reason that's where the mouse is, then this would say 250, 250, and the screen point to ray will shoot a ray directly in the same direction as the middle of the camera. But assuming that your mouse isn't right in the middle of the screen, this ray is going to be offset. Okay, I know we're a lot of in-depth information here, trying to keep it hopefully beginner-friendly, but maybe I'm going too much. Let me know in the comments. So now that we've got a ray, how do we find out if we actually hit something? Well, what we're going to use is the physics system for this. There actually are a few different ways that you can test for collisions with rays for different things, but our box here, our cube, has a collider on it, a box collider over here. It just so happens that the box collider, if I turn off the mesh renderer, you see the box collider very clearly. Obviously, the box collider is set to be exactly the same dimensions of the cube. So we're going to use the physics system and ask the physics system, hey, does this ray collide with anything? Very easy. Physics dot raycast. We're going to cast a ray, and in the most minimal version, we can just pass it a ray like this. And this will return true or false if we hit something. So let's go ahead and give it a debug.log. Yes, hit something. So let's go ahead and hit play. So now what I can do is I can click. And if I click off the box, nothing happens. But the second I click on the box, we say, yes, we hit something. Because every time we click with get mouse button down, we do this raycast, well, we do it here. And if this returns true, then it means we hit something. But of course, the big question is, what the hell did we hit? Physics.raycast only returns true or false, nothing else. However, we can get more information. There is I think it struck technically over here, I don't know. Raycast hit, this class type that you can have, which historically, for whatever reason, you tend to call the variable for that hit info in all the examples for Unity ever, so we're going to go with that. This is something you don't have to instantiate. We can just leave it empty or null at this point. But we can pass a reference to this variable as an out parameter to raycast. Raycast's got like well, you can see here, 16 different variants over here. So we're going to use a variant which requires a ray as the first parameter and an out parameter for the second, which is a raycast hit. Hit info will now contain a lot of information about what we hit. So now let's change our debug log and say, yes, we hit. And hit info, again, contains much information. Specifically, it contains information as to what collider we hit. So this would point to the box collider on the cube, which is something that has a game object, which has a name. So now we can find out exactly what we hit. So let's go back to Unity. Let's hit play. And if I click here, yes, we hit cube. Hey, that's fantastic. We hit cube. All right, good. All right. So let's assume that regardless of what we hit, we now want to go, now let's spawn a new object. So we hit a cube, so let's go and spawn a new object. Ideally, this is going to be another cube attached to our side. So I'm going to start off, I'm going to make a prefab out of this cube. We will be making some significant changes to the setup of this cube prefab later on, but for the sake of expediency, I'm going to take this cube, I'm going to drag it down to my project, make a prefab. Actually, I think what I'm going to do is make a prefabs folder and put the cube prefab in there. Excellent. Now, in our script over here for our mouse manager, we're going to go and make, and again, we'll make some changes to this later on, but for now, we're going to make a public reference to a game object, which is going to be called the prefab to spawn, or something like that. Very wordy, but that's okay. Because it is public, that means that now, if I go to the script, as soon as it's done compiling, if I look at the script, it's got a placeholder here, the prefab to spawn, and I'm going to drag the cube into that spot. So now, in our script, prefab to spawn has a reference to a prefab. And we can now instantiate that into the scene. So the way we do that is we do use the instantiate function over here, which is part of the, it's part of mono behavior, which is why we don't have to like preface it with anything else. So we're going to instantiate the prefab to spawn. And if I go and just run it like this, what's going to happen? Let's hit play. You're not really going to see anything in here. Pay attention to the hierarchy over here. Notice how we have one cube exactly. So now if I click on this cube, I have a clone. Many clones. Every time I click here, we are raycasting, we hit something. Actually, it's interesting. The first time we hit cube, the second time we actually hit cube clone. Because they're right in the same position, it's sort of indeterminate which one we would hit with our raycast. But in this case, we end up hitting the clones. But in any case, every time I click and we hit something, we spawn a new copy of these cubes. Now, they happen to be in the same position as the original one. Why is that? Well, by default, when you use instantiate, the position that the object gets instantiated in is actually based on, in the prefab, the transform setup over here. Oh, just realized our root cube is currently not centered. Let's go ahead and fix that. I'm going to, the cube in the scene, I'm going to center it. And the cube in our prefab list, what I'm going to do is, I'm going to tell it an X of 1, a Y of 0, a Z of 0. So this is in our prefab list. We've done that. So now, when I click on this cube, the new one shows up over to the right. Then every subsequent one also shows up at this X equals 1 coordinate, because that's in the prefab. Clearly, we don't want to use the prefab's coordinates for our position. That doesn't make any sense. What we need to do is assign it a position. And instantiate does actually have another variant over here. Let's get that parent one. I'm going to look at this one over here. This variant where you're allowed to give it a position. So a new vector 3, for example, with some kind of coordinate. If you do that, you also have to include a rotation, which for now, I'm just going to give quaternion.identity. Oops. .identity. Oh, if I spell it right, it helps. Okay. Quaternion.identity. Quaternions are the is the class type that describes a rotation. It's slightly more advanced math than just straight up vector stuff. Just because I don't know, it's hard to explain just casually, but it's a little bit more wonky to work with directly, but it's the best way to describe rotations because it avoids gimbal locks. And you know what? Let's just gloss over that for now. That's fine. But this variant of instantiate allows you to feed in some positions. So let's say I give it a Y of 2, for example, and then we go ahead and instantiate this, and I hit play. There we go. The new cube spawns in with a y of 2. All right, that's fine, but obviously that's not what we're looking for. So we're spawning a new object. Where should the object spawn? Well, that's actually something that we're going to completely answer in the next video. But for now, just to make it a little bit more interesting, I'm going to make a vector 3. I'm going to call this something like spawn spot. And rather than instantiate, you know, a vector 3 with some coordinates, what I'm going to do, in hit info, it's got a really interesting property called point. HitInfo.point is the actual point at which this collision occurred, in which case this is the exact point in which the ray hit the object. So if we use that as the spawn spot, like that, now our boxes will spawn wherever we click. So I'm going to go and click right over here in the top right corner. Ooh. Bottom left corner. Ooh. What about on this new box over here? Oh, excellent. And then let's try to click right in the middle. Oh, didn't quite pull it off. A little lower. All right. Well, that's looking kind of interesting. Obviously, not what we're going for in the end. What we want, instead, is we do want the objects to sort of like lock in a little bit on a side. We sort of don't care about the actual click point because we want to build a very nice organized structure where things click together like, you know, Lego bricks or something like that. So we don't actually want to use the exact click point itself. We want to use something a little bit smarter. That will have to wait until next time, though. I hope this is going to be a tutorial that you enjoy. Because it is the first video of a series, do always appreciate the comments, the likes, the favorites, the subscribes, all that kind of thing. And I will see you guys next time. Thank you to all our September patrons, i.e. people who've pledged in September and are supporting the videos from October to early November, and especially these Mike Check supporters. We've got Yuko Finn, Ole Peter Talgo, Adam Conway, Drazian, Jan Torrevel, Adjective, Michael McClintock, Aaron Doibson, Craig Mortel, Stephen Wendell, Julien Auger Lafont, Marius Fieldvold, Speedy Savant, Stephen Stager, Valiant Cake Fiend, Wes Olenboving, Jason Yanity, Kale the Quick, Neil, Blakey, Milner, and everyone who's watched, shared, favored, and subscribed to the series. Thank you very, very much.